Hey guys, Mr. Nichols' head floating in space. Hopefully you guys are doing okay. It's pretty cold out here. I don't know about you guys. I hear it's pretty warm back in the Denver metro area. But yeah, I hope you guys are doing great. It's been a while since I've seen you. I gotta say, I really liked a lot of your guys' responses to our Enter the Crime Scenes last week. It was really nice to be able to just hear what you guys are up to and what movies you guys are watching and stuff like that. So today we are going to be starting to talk about one of the last topics of the semester. What? Seniors, can you believe it? 2 weeks left. Wow, that's bananas. Everybody else, 2 weeks after that, and summer's already here. Wow, this is just craziness. So one of the last concepts that we're going to be talking about here this semester is going to be fingerprinting. So one of the most essential skills that every forensic scientist should know how to do. So today we're going to just be talking through some notes. It's not going to be nearly as involved as that one that we had for DNA and forensic science. So I'd like to get that going as quickly as possible here to respect your guys' time. Before we start that though, I do want to say that I was really impressed by how you guys did with our unit tests last week. I really wasn't sure how it was going to go taking a test in this remote environment. I had no idea what was going to happen, and you guys did really well. So I was really impressed by how you did with that. So kudos to you guys, and triumphing over adversity right now. I know you've got a lot going on, everyone. So, like I said, today we're going to go ahead and transition into talking about fingerprinting. So, it's kind of similar to what we did before. I have a set of notes that we will just be talking through here. So let me go ahead and share my screen. I did also post a document form of this if you'd like to print it out and take handwritten notes, or if you want to maybe convert it to a Google Doc and just edit it on your own. Maybe if you're watching this video on a phone, or if you have a second device you can use, or if you have it kind of side by side, that would be a way that you could kind of document that. So let's go ahead and get started. So I'm going to go ahead and share my screen here. Okay, so now realistically, we obviously are going to have to streamline quite a bit for the remainder of our time here this semester. Obviously, we're getting pretty close to the end, which is crazy. So we're really only going to focus on a couple skills with fingerprints. So what you'll need to be able to do is you'll need to be able to identify the general shape of the fingerprint, and then you'll also need to be able to identify some of the what we call minutia. So minutia are basically the small little parts of your fingerprints that are unique specifically to you. Where those points of minutia are is what we use to identify someone based on their fingerprint. So let's go ahead and get this started here. Now, fingerprints have actually been used quite a bit throughout human history. So they were first used as identifying markers for things like contracts. It was actually the ancient Chinese that were able to figure out that everyone's fingerprints were unique just to them. So it wasn't until later into the late 1700s, 1800s that we started to really use it for crime scene analysis and to identify individuals here. Here we go. Sorry, I don't have a body, so it's kind of hard to tap the buttons here. All right, so, but what exactly is a fingerprint? Well, if you take a moment and actually look at your hands, you can see these small little ridges, and you can kind of look at the general shape of what that should look like down here. So these small little ridges are essentially an evolutionary advantage that your ancestors developed to help you hang on to things. They increased the friction between objects. If we didn't have these ridge patterns, it's technically what they're called, it would be much harder to grab objects that were smooth. So we developed this for better ways to hang on to things. So these friction ridges are actually what we're looking at when we're identifying someone's fingerprints. Now, what's actually left behind, so if you were to dust an object for prints and be able to come up with something that looks like this. What you're actually looking at is you're looking at the oils and the sweat, the water that was left over from the physical contact of their finger to that surface. So a couple things about fingerprints. So fingerprints are what we call individual evidence. So if you remember from way back in the day, individual evidence means that we can link it to one specific person. So no two people are going to have the exact same fingerprint, not even identical twins. So fingerprints are going to be completely unique no matter how much genetic similarity you may have to someone else. So now, a fingerprint is actually mostly unchanged for your entire life. So even if you were to, say, cut some of the skin off of your finger, or you might have heard, in movies and things like that, people who burn their fingerprints with acid or with heat, your skin, if it grows back, will still have that exact same ridge pattern. So you can't cut off that pattern. So it's something that's replicated throughout your entire life here. Okay, now it's these ridge patterns that we use to identify people. Now when we're looking at ridge patterns, we've got to look at a couple key characteristics. So we've got cores and we've got deltas. Now the number of cores and the number of deltas that a fingerprint has helps us determine what general shape it has. Okay, so deltas are going to be characterized by this little, it almost looks like a little triangle shape. And you can see basically 3 sets of ridges that are coming together. A core is going to be one of these long protrusions, which basically makes a loop around the outside of it. Okay, so you'll have this central line that essentially goes out and then comes back, and then you have other ones around it that just keep going and going. Notice how it extends all the way to the edge. It doesn't end at a particular point within the fingerprint. So let's start looking at some examples. So we have 3 general categories of fingerprints. So we've got arches, loops, and whorls. Now, as we can see by this distribution, most people are going to have some form of a loop. Now, unfortunately, loops are actually, radial and ulnar loops are some of the harder ones to identify. It's actually pretty tricky to tell the difference. That's definitely the hardest one. Arches and whorls are pretty characteristic and pretty easy to identify. Okay, so let's break down each of these here. So an arch. So an arch, which let me try and bring my hands into existence. Okay, perfect. So arches are basically going to be a loop that looks like, or sorry, not a loop. Excuse me. So it's going to be something that goes up and then comes back down. It's pretty clear if you look at this shape here, what an arch is. Now, if we look at arches, there's going to be 2 main types. So we have a plain arch and then a tented arch. So a plain arch is going to be very round. It's going to be a soft, round hill you can think of. And then a tented arch is going to be coming up to this point. And if you look really closely here, you can see that there's a vertical protrusion in the middle of this arch here. So a tented arch is going to come and it's going to push up very quickly, whereas a plain arch is going to be very round at the top. Now, one thing to keep in mind with arches is that they are not going to have a delta. So there is no deltas on an arch. So if you don't see any deltas, you automatically know it's most likely going to be an arch. Okay, so a tented arch, you could kind of think of it as being a little tent that's pitched right here. So if we look, we've got this little triangular shape, and we've got this section that pushes up in the middle. So that's going to be a tented arch. And again, plain arches are going to be very smooth, very rounded at the top. Okay. All right, so then we have loops. Again, loops are probably the hardest ones to identify here. So loops are going to have 1 delta, and then they're going to have 1 core. Now, we have 2 different names that we use to describe each of these different types of loops. Now, the way that we do this is depending on what hand it's going to be on. Now, if you think about your arm, which, I don't have any forearm bones, so that's a problem. But if you look here, the side that's running alongside your pinky, so this side here, this side right here, is going to be your ulnar bone. That's where your ulnar is. So it follows your pinky. So even if you rotate your hand around, your ulnar is going to follow your pinky. Okay. Now, your radius is going to be the bone that follows your thumb. So if you look here on this side of your hand, if you have your thumb, okay, that is going to be your radius. So if you were essentially to hold your hands out in front of you, which is kind of hard for me to do in this camera, but if you were to hold your hands out in front of you and look at them, you would say, okay, if I had a fingerprint on my right arm, and it does what we call opens up to your thumb, which basically if let's look at this image down here. So let's say that this image was from a right hand. Notice how this arrow is showing how it's opening up towards where the thumb would be. So hold out your right hand in front of you so that your palm is facing away from you, and imagine that this fingerprint was on your thumb. So this is going to be opening up to the thumb direction, aka your radius, so that would be a radial loop. Now let's say that this is from your other hand. So again, we're still looking at this image on the right. So if you've got your left hand now, and if we found this exact same fingerprint on your thumb, where's my cursor? There it is. If we found this exact same fingerprint on your thumb, now it's opening up to your pinky. So it's opening up to the left. If you have your left hand, it's opening up to the other side. And remember, the pinky is going to run alongside your ulnar. Okay? So, like I said, this can be a little tricky, but I would recommend holding your hands out and trying to remember that. So it is going to be really important to pay attention to what hand a fingerprint came from. Now let's look at this other one as an example here. So if we have, move this out of the way. So if we have this fingerprint now, let's run through the same exercise. So if we have our right hand, so you have your right hand, hold it out in front of you. Notice how this is opening up to the left. So it's opening up, we're looking at our right hand towards your pinky. Okay? So that means that this would be, if it's on our right hand, this would be an ulnar loop because it's your pinky side, opening up to the right. Now let's say this was your left hand. Okay, so you've got your left hand, hold it out in front of you. Same thing, if we found this fingerprint here, now, and it's on your thumb, it's opening up towards the right. So that is going to be towards, which I recognize this is flipped, so it might be a little bit tricky for you guys to see. I'd recommend doing it on your own. So it's following your thumb, it's pointing towards your thumb, so that's going to be pointing towards your radius. So this would be what we call a radial loop. Now, one thing, I don't think I mentioned this clearly, but loops are always going to have one delta and then one core. So if you only see one delta, which here you can see one here, and you can see one here, those are both the triangle shape. So there's one delta on each of these, and then there's one core. Okay, so again, think about what direction that your core is opening up to. If it's opening up towards your thumb, again, if your hands are facing away from you, it's going to be an ulnar loop. If it's pointing towards your pinky, that means it's going to be an ulnar loop. So be very careful with that. It's pretty tricky. It'll take some practice to get that down. Okay. All right, so here are some other examples of loops. So you can pretty clearly see the core here, and then, you can see the core right here, and you can see the delta right here. Here, the delta's kind of off the screen, but you've got your core right here. All right, so here we have a whirl. So we had arches, we have loops, and we have whirls. So whirls are actually going to be pretty easy to identify, but there are multiple types of them. So telling the difference between them might be a little bit tricky. So a whirl is going to have two deltas. So we can really clearly see these two triangle shapes, and then you have this spiral pattern in the middle here. Okay, so if we look here, we've got a core in the middle, and then we've got 2 deltas on the side. Okay, so let's look at each of our different kinds here. So we've got 2 deltas, 1 delta here in this picture, 1 delta here, and then we have 1 core that's in the middle. Now, if it's really symmetrical, if you could draw a line down the center of this and it looks approximately the same on both sides, that's going to be what we call a plane whorl. So a plane whorl is going to be very symmetrical. Now, a central pocket whorl is going to be very similar to a plane whorl, except one of those deltas has pushed closer to the center core. So it kind of gives it this almost like kind of crooked diagonal looking shape for the core. So this delta here has moved in towards one of those cores. So if you were to draw a line down the center of this, notice how it is not symmetrical. It is not even on both sides. Okay, but again, we still have 1 core here, or sorry, 1 delta here, 1 delta here, and then we have a core in the center. Okay, now with this type of, with the whorls, we have a couple different other categories that kind of just end up being a little bit of a mixed bag. So we have double loops. Those ones are pretty easy to identify. Essentially, there's going to be 2 cores that almost look like they're spiraling into each other. So they kind of make this spiral pattern in the middle. So here we have 1 core here, 1 core here, a delta here, and a delta here. So we know that there's 2 deltas. So we automatically know it's going to be a whorl there. So anytime we see that spiral pattern, that's going to be what we call a double loop. Now the hodgepodge kind of, just catch-all, grab bag category of fingerprint for anything that doesn't fit into any other category is going to be what we call an accidental. So if we look here, man, this picture is just a mess. So it's really difficult to identify what that is there. So you can kind of see a delta here, and then it looks like there's 2 whorls, but they're not really wrapped in on each other. They're just kind of there. So this would be what we call an accidental. So if something doesn't fit into any other categories, that's going to be what we call an accidental. So double loop, here's a picture of one. Again, they're pretty easy to see. You've got a core here, and you've got a core here. Okay, so that's pretty easy to identify. Again, accidentals, they're kind of just a hodgepodge. This one, we've got a delta here, and then we kind of just got this central section in the middle. All right, here's another picture of an accidental. See, it's very difficult to see any of those deltas or cores. It's just kind of a mess. So that's going to be an accidental there. Okay, so at this point, I'd like you to go ahead and pause the video and try to identify what each of these ones are here. Okay, so we're going to go ahead and pick this back up here. So if we look at letter A, so here we've got a delta here, and the next question we should ask ourselves is it symmetrical? Oop. Yes, it is, so that is going to be a plane whorl. Okay, so if we look at this one over here, it's going to be a double loop. Okay, so you can pretty clearly see the 2 cores. So we've got 1 core here, another core here that are kind of just spiraling in on top of each other there. So that one's pretty easy to identify. This one might have been a little bit tough. You'd have to look really closely at this point in the center. So this is going to be a tented arch. Notice how it comes up to that characteristic triangle point. So that's going to be a tented arch. This one's a little bit tricky, which I don't think that I mentioned this, but for pretty much any of our times we're identifying, we're just going to assume that we're using the right hand. So if we look here, if we've got a delta right here, we've got a core right here, that means that this is going to be a loop of some sort. Now we need to figure out which way it's opening. So again, we can assume that this is the right hand. So if it's the right hand, it's opening up to the left. where'd my cursor go? It's opening up to the left, it's opening to the left. So if you hold out your right hand and it's opening up to the left, that's going to be pointing towards your thumb. So this is going to be a radial loop. Okay. And then last but not least, we have a plane arch. Again, those are pretty easy to identify. They just are very rounded along the edges there. Okay, so that kind of takes us through our first part here for our notes. The second part is really pretty easy, I would say. So this is when we're talking about minutia. Now, these are the ones that are really the most important when it comes to identifying someone's fingerprint at a crime scene, because these are the general points that we look at to identify someone here. Okay. All right, so essentially what we're looking at are points of uniqueness in fingerprints. They're these small little unique ridges that make specific patterns that are identifiable. And the position of where the pattern is important as well. So now, although we asked to have a lot of points of similarity to identify someone, there is no legal standard in the United States for how many points of similarity are required to identify someone. Typically, we look for approximately 8 to 12 points of similarity. The United Kingdom actually has a minimum of 16 points of similarity to identify someone, and Australia requires 12. But there is no international standard, and even in the United States, there's no requirement for how many points of similarity someone's fingerprints should have. So if we look at this here, and there's a pretty similar diagram to this on the back side of your notes. Here, this identifies some of the common shapes that we see when we're looking at minutia. So obviously we've talked about cores and deltas. They're that characteristic kind of long rounded shape for a core, and then a triangle shape for a delta. Then we have ending ridges. Okay, so ending ridge is basically, and when we say ridge, we're essentially talking about the line that we see in a fingerprint. An ending ridge is going to be where a ridge comes to an end. You'll see a lot of these names are pretty obvious here. But wherever you have a long ridge that comes to an end, that's going to be what we call an ending ridge. A short ridge is going to be a ridge that's approximately 3 to 5 millimeters long, which I'm never going to expect you to pull out a ruler or anything like that and measure these. But a short ridge is going to be just a small little ridge that's in between two other ridges. Now, this one is one of the most common ones that we'll see, and that's called a bifurcation. So bifurcation is basically where you have one ridge that branches off into two. So think bicycle, two wheels on a bike. So that is where one ridge breaks off into two. So a hook, that's going to be a little bit tricky to see. Basically, it'll be a straight line for a ridge and then a little piece that breaks off from it. Hooks are actually pretty rare. They're not one of the more common ridges that we see. An eye, that's going to be where we have kind of this little opening. So you'll have basically two bifurcations that are right next to each other that make an opening in the middle. Then we have a dot. So a dot, as you could suggest, is basically it's just a speck, a point, one point inside of the minutia that where basically that ridge comes together. Now, one key difference that I see a lot of people mix up is mixing up the short ridge with the dot. So the dot is going to be pretty circular. So what that means is it needs to be about the same length as the width. So if it's any longer than it is wide, chances are it's going to be a short ridge. So it'll be a short ridge versus a dot. Okay. Crossover, that should be pretty self-explanatory. It's where you just have two ridges that cross each other. And then a bridge is where we're going to have basically two parallel ridge patterns, so two parallel lines on the ridges, and then a line that intersects both of them. So that's going to be a bridge there. So again, kind of breaking this down, I really don't think we need to talk about this too much, and I want to, as I said, respect your guys' time. So a bifurcation is going to be where you have one ridge that breaks off into two. That right there. And then moving on from a bifurcation, we have bridges. So notice here we have parallel ridges right here going along this. And then we have one ridge that cuts across or intersects more than one. Okay. An eye, so those are going to be, remember these little openings, essentially two bifurcations that are just connected to each other. An ending ridge, so notice how this is a relatively long ridge, and then it comes to a stop. It ends right here. So that's going to be an ending ridge. Okay, a crossover, it's basically just going to be an X. Those are pretty easy to identify. Dots, so a dot, if you look at this one right here, notice how the length is approximately the same as the width. So dots are pretty characteristic. We don't want to mix them up with a short ridge. So if we look here, there's a pretty big difference between this and this. So make sure that if it's longer than it is wide, it's a short ridge. If it's about the same length as it is the width, that's going to be a dot. Okay, and then a hook, again, is a bifurcation, basically a little branch that comes off of one main ridge there. So if we look really closely right here, this would be an example of a hook. Even something like this here, I probably wouldn't call this a hook. I would probably call that an ending ridge. So hooks are going to be pretty small. So like this here, this right here. So just kind of keep that in mind, which I am going to give you guys a little bit of wiggle room on those. So just keep that in mind there. Okay, so at this point, that pretty much covers everything that we're going to talk about this unit, because it's pretty short, for identifying fingerprints. So what I'd like you guys to do is, wherever you took down your notes, which obviously you can pause the video and go back if there was something that you missed or if I went too fast, but I'd like you to post an image of your finished notes on this assignment for today. And then in addition to that, what I'd like you to do, which obviously, sorry, I should have mentioned this. If you just made a copy of the notes in Google Docs and you just typed in your answers or typed in your work, that's totally fine. You can just post that there, or you can post your images. Either way, that's perfectly fine. So to kind of give you a heads up of where we're going with this, next class period, I'm going to have you guys actually collecting your own fingerprints. Unfortunately, we don't have access to the fingerprint powder that we would have used in class together. So we might have to kind of be a little bit flexible with that. To be honest, I'll be posting another video to show you guys how we're going to be doing that here on Thursday and Friday of this week. So I hope you all are doing well. Hopefully you guys, that all this was clicking with you. Again, it's really not too difficult. But yeah, hopefully you guys are doing great, and we'll talk to you next time. See you later.